Hi, and welcome to the video on the two-step mole conversion practice problems. In this video, I'm going to go over the model problems that you find in the beginning of these 5 problems. And then you can use this to sort of help guide you for your practice. Now, before we get into the model problems, I want to go over the key information that's here. First off, in a two-step mole conversion problem, what you are asked to do is to convert from a given amount of a substance to a different amounts of that same substance. Now, what makes this a two-step mole conversion problem is that both your given and what you're asked to find, those amounts, will not be in moles, but you have to go through moles to find them. So, for example, if you're given the concentration of a solution and you want to find out the mass of the solute in that solution, you would start with concentration and convert to moles. And then you would go from moles to your mass. So those are your 2 steps. You're doing 2 conversions. So how do we solve 2-step conversion mole problems? It's the same thing as we've done with 1 step, where first thing you want to do is identify your given and your find. Then you want to map out a plan. And remember, for your plan, you have to go through moles. So as we saw in the example, if we're given the concentration of a solution, we would then convert it to moles, and then from moles we would convert it to mass if we're asked to find the mass. Now when it comes to solving, there are 2 ways that you can solve. You could use the equations that are along the arrows and just plug in your values and solve for your unknown, which is our plug and chug method. Or you can use dimensional analysis. Now, for dimensional analysis, this is sort of what the setup looks like for 2-step mole conversion problems. You start off with your given, you put it over 1 to make it a fraction, just to make it easier to do the math. And then you're going to multiply it by 2 conversion factors. The first conversion factor is going to come from the given. So, in the case of molarity, and if you're looking at using a gas, the gas equation, there really aren't conversion factors that we can use for that. We can actually do one for molarity, and I will show you how to do those, but we really don't focus on using conversion factors for these 2. However, for something like mass to moles or moles to mass, your conversion factor will be 1 mole is equal to the molar mass. From number of atoms to moles, it will be this 1 mole is equal to 6.02 times 10 to the 23 atoms or molecules. And if you have a gas at STP, you can use the 1 mole is equal to 22.4 liters at STP as your conversion factor if you're asked to find the volume. So you would use this information and you would set it up in such a way that the units of your given cancel out, so they have to be opposite, and the units of what you're asked to find stay. And then you would just multiply your 3 fractions to get your find. So this is sort of what it looks like. Final thing, units are super important here. And when you're converting, when you're using mass or volume, remember that for these equations, your mass will be in grams. So if you need to convert it to kilograms or vice versa, use this information here. Your volume, whether it's for the volume of a gas or whether it's the volume of a solution, will be in liters. So if you need to convert it, use this information here. And finally, for temperature, if you want to convert it, you're going to use this information here. 200 Kelvin is equal to degrees Celsius plus 273. Okay, so that's sort of just a brief overview of the information. The next video, I'm going to show you how to solve problem 1.